Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, question number 1 about our solar system. The solar system has 9 planets. True or false? Justify your answer. So we can just count these out. It is false. There are 8. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, not Pluto, because Pluto is a dwarf planet. So that's how I justify this. Right, next question. There are no natural satellites, only artificial ones placed in space by humans. Nope, that is not true. We can consider our moons to be natural satellites because they are objects that orbit around planets. And there's not just our moon for Earth, there are moons for different planets too. Jupiter, Saturn have many, many moons themselves. So why did our model of the solar system change over time? So we started with geocentric, the idea that planets and the sun orbit the Earth, so that Earth is at the centre of our solar system. But then as we made more observations and did more calculations, that model changed to heliocentric, where you have the sun in the middle of our solar system and the planets orbiting the sun, which is obviously the model that we have now. And there was some friction against this model because it seemed to be going against the church at the time, where God would have put Earth at the centre of the solar system. That was people's problem with shifting the viewpoint to the sun being at the centre of our solar system. Okay, there is an asteroid belt just beyond the orbit of Mars. What's an asteroid and how does it differ from a moon and a comet? So, an asteroid is a lump of rock and metal. Moons orbit planets and asteroids in the asteroid belt don't. They will orbit the sun, and a comet is made of ice and dust and always has this highly elliptical orbit that it moves around in. Okay, what is the trend in the data below, and then to explain it? So we've been given orbital velocities and distance from suns, and if I look at my distance from the sun first, I can see from left to right it is increasing. Then I look at my orbital velocities and they are decreasing from left to right. So the further away we get, the smaller the velocity. That is the trend that I'm seeing here, and I don't see any anomalies to that trend. Distance from the sun affects the gravitational force that you feel between the planet and the sun. Okay, so that may be a clue to govern what's going on here, and indeed it is, because the smaller force of gravity you feel, so the planet furthest from the sun, the one all the way on the right here, Uranus, that distance of 4,515 times 10 to the 6 kilometers, has that lowest velocity, that 5.4 kilometers per second, because it needs that lower velocity to stay in orbit, okay, because the force is smaller on it, its centripetal force. A mystery planet is orbiting a star. One orbit covers a distance of 5,000 megameters and takes 25 days. What is the orbital speed in meters per second? So don't be put off if you see something like this. There isn't some random formula you haven't learnt yet that you need to learn. We're just using our speed equals distance over time. We've been giving our distance 5,000 times 10 to the 6 for meters, dividing it by our time, and that's in days, and I need it to be in seconds. So 25 days times 24 to get the total number of hours, times 60 to get into minutes, times 60 again to get into seconds. That's why I've written that 3,600 there. That's just 60 times 60. And if I divide those two things together, I get 2,314.8 meters per second. Okay, orbit. So on my left, what affects the speed of planets' orbit? of a planet's orbit at y. So that will be the mass of the planet and the distance from the star. So why would that be? Basically, it's those two factors that contribute to the force of gravity which is acting between your planet and the star. So basically, the larger the mass of your planet and the shorter the distance between your planet and the star, the larger that gravitational force will be. And the larger that gravitational force is, the faster your planet needs to move around that star to maintain that circular motion. Okay, explain why Earth does not fall towards the sun due to the force of gravity. So this is all because Earth has a velocity, which is that little sign there means perpendicular to the force of gravity when it moves round. So rather than gravity just pulling the Earth in towards the sun, what it actually does is pull the Earth round into an orbit rather than into the sun. So if it helps to think about, you can think about the fact that if gravity weren't there, then Earth would just fly off at a tangent away from the sun. So we need gravity there to keep pulling it round, round, round in its circle. Okay, question number 1. What direction does gravitational force act as the Earth orbits the sun? So towards the centre of the sun. So that big ring there is the orbit that my Earth is taking, and that black dot in the centre is my sun, and all those arrows show the direction of the force at any point, always towards the centre of that circle, towards the sun. Explain how an orbit of a comet differs from a moon. So moon is fairly circular and your comet is way more elliptical, which means that its speed will be different at different points in its orbit. So for something moving around in circular motion, its speed may remain fairly constant, but its velocity keeps changing because its direction keeps changing. Whereas for something which is elliptical, its velocity keeps changing because its direction keeps changing, but also its speed will change as well. So in this diagram here, that black dot in the middle represents the star that this comet is moving around, and when it's off to the left there and therefore closest to the star, it's moving faster, and then as it gets further and further away from the star, it moves slower off to the right. Okay, what is aperture? How does it affect image quality from a telescope? So aperture is just to do with the size or diameter of the lens, and basically the larger the lens, the better image that you get, because more light, which is coming from whatever object it is that you're trying to see, can be therefore captured by the lens. Explain why a village in the mountains is a more suitable choice than a sea-level town for a telescope. Okay. Two things going on here. First thing is to do with altitude. So if we're in the mountains, there's less atmosphere above us, so you will get less light from your object being distorted from the atmosphere, so that will help to create a clearer image. And the other thing is, maybe not always necessarily true, but a village is less likely to have as much light pollution than a town. There'll be fewer street lamps and lights in people's houses and things like that, which would also be disrupting being able to tell what's the light being captured from the object very far away that you're trying to look at versus what is the light which is accidentally being caught from these human settlements. Okay, how do computers aid the capture of quality images? So if you have a computer taking images from your telescope rather than a human there, basically you can collect lots of data because you can run it 24 hours a day, and then you can use all of that data to actually create a clearer image of your event that you're trying to watch. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, tips and tricks. So first one is planets. Learning their names and the order. Maybe you'd like to use a mnemonic, so mine is my very easy method just speeds up naming planets, but be careful because the P for planets stands for Pluto, which of course is not a planet. So maybe you can think of a better mnemonic that does not involve Pluto at the end. But we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay, weight versus mass. So just a reminder, we've done it in previous topics, but your weight is the thing that changes with G. So you will experience different weights on different planets because there are different gravitational field strengths on different planets, but your mass is the same everywhere in the universe. Accelerating Earth, yes. Don't be tempted to say just because your speed is constant as you move around in a circle that you're therefore not accelerating. You need to be aware that when planets are moving around the sun, since their direction keeps changing, their velocity keeps changing, and therefore they are indeed accelerating.